So to convert that to CFM, we just multiply by a 0.6. I'm not getting precise here. So now you're at 36, but that's at 50 cycle. So now you add 20%. And you get into the 43, 45 CFM. That's what you have. You don't have 63 CFM. So you have to be careful when you buy pumps, because I don't know of any manufacturer in the U.S. that makes vane pumps anymore in the United States. So the key is, look at the label. Sometimes they'll say liters per minute. Sometimes they'll say liters per second. Sometimes they'll say cubic meters per hour. But if you want to use cubic feet per minute, you have to make the conversion, and you have to understand that. And bigger does not necessarily mean better. If you have a restriction, the smallest point in the manifold will determine the conductance of the gas coming out. What we do with our formula, and this is pretty clear, as the molecules get further apart, it makes more difficult to trap those molecules and evacuate them. Okay? So, we have a formula. 2.3 times the log over P1 over P2 with a service factor. Okay? From atmosphere to 10 torr, the service factor is 1.2. From 10 torr to 1 torr, it's 1.3. From 1 torr to 10 microns, it's 1.4. So that will give you an idea of how far the molecules have expanded as the pressure goes down, and makes it more difficult. The pumping speed slows down the further you get in vacuum.
Is that where the pumping speed curve would come into play?
Of course. Everybody sees the pumping speed curve. It's not very good, say at atmosphere or 500 torr or 400 torr, because you have density and it requires more horsepower and you're compressing more gas. Now, as you go down, once you get most pumps, two-stage vane pumps, for example, or dry pumps or whatever, have full pumping speed down to 1 torr. However, below 1 torr, then it drops off dramatically because of the mean free path, or to put it more simply, the distance between the molecules in the chamber. Now, I have had people come to me and say, well, we want the best pump you have. This will blank off at 5 times 10 to the minus 4. And I said, well, you're only running at 1 torr. Why would you want that? Oh, I want the best. Well, no, that's not good. It's not good for a two-stage pump to be running at 1 torr, because the oil flow inside is not going to be as efficient as it is at 10 microns.
A second stage vacuum pump versus a single stage?
Yeah, a single stage
is 1 torr.
A single stage vane pump can blank off at
minus
half
1.
A torr,
yeah.
half a torr.
Okay.
But it has no speed at that. Okay? People shouldn't be hoodwinked into believing that they can pump on a system like a two-stage vane pump, 5 times 10 to the minus 4. Okay? That's a blank off. That's pumping nothing. That's it blanking off the inlet and taking a partial pressure reading at the inlet. Okay? Well, no one buys a pump to pump nothing. So if you're going to pump something, it's not going to be 5 times 10 to the minus 4. It might be, at best, 3 times 10 to the minus 1, something in that range, okay?
Okay.